Humankind, definitely since the beginning of the Industrial Revolution, started to use more and more energy, and the source of that was and still primarily is fossil fuels. Now, we have reached a point where nature alone cannot take care of the carbon dioxide excess in the atmosphere, so we do have to use the methods that we have developed to accelerate that, to take more carbon out and put it away. Given the urgency and our lack of action in that area of regulating the greenhouse concentration of the atmosphere, mainly CO2, has put us into a position where we are what we call a decisive decade. That means we are at a point where the time for thinking about the problem has run out.
Our global society needs technological solutions that can remove carbon dioxide from the atmosphere, and we need to do that in ways that don't consume too much energy, that consume minimal amounts of water. And so that means that we need new materials, new systems, new processes, new deployment strategies for carbon capture technology that can scale to meet global emission sizes.
There's a whole range of ways in which we can reduce the carbon footprint. But there's increasingly concern that we just don't have time for all of that. Here at ASU, we're looking at one particular kind of carbon capture, which is known as direct air capture.
Direct air capture is the process of deploying sorbent material, have that come in contact with the air, and pulling out a very dilute feedstock, carbon dioxide, from the air. So for every 1 million molecules floating around in the air, 400 of those are carbon dioxide. And so we're kind of looking for that needle in a haystack, and we need materials that can very specifically grab that carbon dioxide out of the air and hold on to that until we tell it to let go under low energy conditions.
In order to deploy at the million-ton or billion-ton scale, you need a technology that can actually perform at that level. You need places where you can store at that level. You need a policy environment that is conducive to operating at those scales, and you need a lot of money.
We're also looking into what do we do with that CO2, right? So at 40 gigatons of CO2 emitted per year, permanent storage has to be one of the options. But there's also beachhead markets that are available now, right? Food and beverage industry, sustainable fuels, and a host of others that we're exploring, and how we can adapt our technology for some of those specific applications. So the Center's kind of taking a holistic view and approach to developing this technology.
It's extremely important as we think about this energy transition that we recognize that there can be no gaps as we transition from one energy form to another. You get gaps, then you get price spikes, you get rolling blackouts or the inability to transport, and then you get civil unrest. These two new systems have to knit together perfectly.
We are at a point where the time for thinking about the problem has run out. We are at the point where we have to act now. This is the time. This is the time to act. It will come with opportunities, but it also will come with urgency. So it's our choice how tomorrow will look like.